Hello, and welcome to this video demonstration featuring zero downtime volume migration and synchronous or asynchronous data mobility between storage systems using Live Volume and Storage Center. In this video, we'll take a look at some of the new features found in Storage Center 6.5 and Enterprise Manager 2014 R2 relating to Live Volume and synchronous replication. We'll start out with a few slides to show some design and architecture and how Live Volume interacts with applications and operating systems, and then we'll get into a live lab environment. In a typical configuration, a storage host is mapped to a volume on a single storage center. Let's call that volume LUN10. When we convert that volume to a live volume, it has the ability to abstract or stretch that volume across multiple storage centers, leveraging the storage host's native ability to support MPIO. Although the volume is located on two different storage centers, from a host perspective, it sees it as a single volume. In this case, LUN10. That's the abstracted volume, or the storage virtualization. As we can see in this diagram, the storage host now has two paths to the same volume. With Live Volume in place and the storage abstracted, this allows us to swap the paths using the storage host's native MPIO abilities. As we can see in the diagram, the storage I/O is now going through the secondary live volume, which has been designated as the primary path. After that change has been made, we can perform a manual or automatic role swap of the live volume behind the scenes. What we've accomplished here now is a live migration of the data or storage access from the storage host perspective from storage host A now to storage host B. If we take a look at this from a virtualization perspective, for instance using products like VMware vSphere or Microsoft Hyper-V, we have the ability to stretch volumes or data stores across storage centers and essentially create a stretched cluster configuration. This will allow us to load balance or migrate virtual machines, either a single virtual machine or a larger number of virtual machines, from one host in a cluster to another, or perhaps from one cluster to another cluster within the same logical data center. Let's take a look at how that works. In this case, we have a virtual machine, or perhaps a group of virtual machines, residing on virtualization host A. That virtual machine is generating read-write traffic to storage center A, which has been configured with a primary live volume. And we can see that LUN10 is the data store where this virtual machine resides on. We can vmotion the virtual machine to another host in the cluster, or again, perhaps to another host in another cluster that resides within the same logical data center. Once this occurs, the virtual machine traffic will go through the secondary live volume back to the primary live volume for a short period of time until Storage Center detects that the traffic is going through the secondary live volume, at which point an automatic role swap can occur. Once this role swap has occurred, the virtual machine traffic will stay local with the primary live volume on Storage Center B. At this point, we've accomplished both a compute and storage migration of a virtual machine essentially at the same time. And again, this doesn't need to be one single virtual machine. Typically, there will be a larger number of virtual machines on any given data store, for instance 10, 15, 20, 50, or more, depending on sizing requirements. Again, this cluster configuration may reside in a single data center, or it may reside across two data centers with some given distance between them, representing a stretched cluster configuration. And to summarize, in Storage Center 6.5 and Enterprise Manager 2014 R2, Live Volume may be built on top of either asynchronous or both modes of synchronous replication, high availability or high consistency modes. Now let's take a look at some Live Volume application and data recovery scenarios. One of the questions that gets asked is, what happens if the primary live volume becomes unavailable? In Storage Center 6.5 and Enterprise Manager 2014 R2, we have the ability to preserve the live volume on Storage Center B. This allows us to recover the applications and services in a minimal amount of time. Because we're preserving the identity and the disk signature of the primary live volume on Storage Center B in this case, applications such as vSphere will not require us to unregister and re-register virtual machines so that we can recover applications and services in a very minimal amount of time. We simply power on the virtual machines at the other site where Storage Center B resides. Another new feature in Storage Center 6.5 and Enterprise Manager 2014 R2 is a feature called Live Volume Managed Replication. This provides some DR capabilities for live volume configurations. Essentially what was added is an additional replication to a third storage center at a third site. A good use case here is for disaster recovery. The replication is managed by live volume and always follows the primary live volume as the source of its data. So for instance, the primary live volume as we see it now is on Storage Center B. That replication then would flow from Storage Center B to the DR site where Storage Center C resides. Should a role swap occur where the primary live volume moves or migrates to Storage Center A, the live volume managed replication will automatically change its replication pattern to use Storage Center A as its source of replication where the primary live volume now lives, and that replication will flow to Storage Center C. Live volume managed replication supports both asynchronous and synchronous replications, including both modes of synchronous, high consistency and high availability. Now consider a live volume configuration where two storage centers, in this case A and B, reside in the same data center. And consider a disaster in the data center which occurs at 12 p.m., impacting all infrastructure, including network, storage, and servers. At this point, we can recover our data at the DR site where Storage Center C resides. This is where our live volume managed replication replica volume resides as well. We can recover our live volume data at the DR site where Storage Center C resides. We have some flexible options in terms of recovering the live volume from the point in time when the failure occurred at 12 p.m. noon, or we can roll back to a previous replay using a view volume, for instance at 11:45 a.m. This data recovery process at the DR data center is automated using Enterprise Manager and predefined disaster recovery plans. At this point, let's go into a live lab environment where we'll use the next-gen vSphere web client as well as the Dell Compellent web client plugin to create a data store, and then we'll convert that data store into a live volume after creating a replication. So we'll go to Host and Clusters. I'll right click on the host, add a data store. We'll choose the storage center to create what will become the primary live volume. It'll be a new compellent volume. Let's call this data store the volume LUN20. Make it 2 terabytes in size, and we'll put it in the vSphere folder. Use the recommended profile. We'll assign an hourly replay profile, and the LUN number will be LUN20. VMFS5, the data store name will be LUN20 following the volume name, and finish. At this point, LUN20 has been created. I can see that here, and it resides on the host TSSRV 214, which is one of the two nodes of my stretch cluster. If we take a look at TSSRV 215, notice that LUN20 does not exist yet. We have not yet created a live volume, so let's start that process by replicating LUN20, and we can instantiate that replication in the vSphere client using the web client plugin. So I'll right click on that data store, and for the replication actions we'll choose replicate data store. And at this point all we need to do is choose a destination storage center. In this case it'll be 64424. We'll assign a QoS definition. Let's go ahead and make this a 4 gig QoS policy for traffic shaping purposes. The destination replica folder we'll place in the vsphere folder for consistency purposes. Next, and finish. So we can see under the running tasks that the replication is currently being created, and that should wrap up in just a few seconds. We can check the status of our replication using the Dell Compellent plugin under the Monitor tab and by selecting the Dell Compellent Views button in the Web Client plugin. Down below we'll choose LUN20 and then Volume Replication. At this point I can see that I've created an asynchronous replication. The status is 100% synced with 0 megabytes remaining, meaning that the volume at this point is caught up on its replication. Now let's move over to the Enterprise Manager client where we can convert this LUN20 volume and datastore replication into a live volume. To do that, I'll highlight LUN20, go to the Replications and Live Volumes area. I see here that LUN20 is currently replicating. To convert this to a live volume, I simply right-click on the existing replication and convert to live volume. I'll choose a QoS policy, and then I want to also choose the vSphere host in my stretch cluster that I want to attach the secondary live volume to. In this case, it's going to be TSSRV215. Click OK. And I'll also choose advanced mapping. I want my LUN numbering to be consistent. So I'm going to make sure, I'm going to force this to be LUN20. So I have consistent LUN numbering across all vSphere hosts in my cluster. Click OK. Okay, at this point our live volume creation should be complete. If I move over to the live volume tabs, I can see that LUN20 is now a live volume, and the primary live volume in this relationship resides on Storage Center 64422, while the secondary live volume resides on 64424. Now at this point, this is an asynchronous replicated live volume. One of the new features in Storage Center 6.5 is the ability to shift between replication types without actually having to tear down and rebuild the replication. So let's do that now. Let's convert LUN20 live volume from an asynchronous to a synchronous replication. We'll edit settings, and we'll simply move from asynchronous to synchronous, and let's make this high availability synchronous. We'll keep the existing QoS policies intact, 4 gig at both the source and the destination, and we'll click OK. Our LUN20 live volume has now been converted from asynchronous to synchronous replication as indicated down below under the Summary tab. Now let's go ahead and create a managed replication for LUN20. This will protect it in the event of a disaster that impacts both the primary and secondary live volume in my stretch cluster. So we'll simply once again right click on the LUN20 live volume and we'll add managed replication. We'll be asked the storage center for which we want to add the managed replication to, and this is going to be the storage center that's at the DR site. In this case it's 64786. Again, I'll choose a QoS policy. This replication I'm going to make asynchronous, and we don't need a 4 gig QoS policy, so I'm going to leave this at 1 gig and then click Finish. At this point, the Manage Replication should be completed. If I move over to the Replications tab, I can see that we now have a LUN20 replication, and it is of the type asynchronous, replicating to my DR Storage Center 64786. Let's jump over back to the vSphere web client, and let's verify that LUN20 is now visible on both hosts in my stretch cluster. So we know that it's already visible on TSSRV214. Let's go to TSSRV215, go to Related Objects, and then the Data Stores button, and I can see that LUN20 is now available on the other node of my stretch cluster. So at this point, LUN20 is visible and essentially stretched across both nodes of my stretch cluster. I can now begin deploying virtual machines to LUN20, and they can be vMotion between hosts and across sites. Back in the Enterprise Manager client, let's go ahead and create a predefined DR plan for our LUN20 volume so that we can have Enterprise Manager assisted DR in the event of a disaster of our live volume stretch cluster. To do that, I'll go to my Restore Points tab, and I'll right-click on the LUN20 volume and predefine disaster recovery. I'm going to choose the DR server that I want this LUN connected to in the event of activating disaster recovery. In this case, it's going to be my DR vSphere host. Click OK. I have the option to choose an advanced mapping. In this case, once again, I would like some LUN consistency. So I'll choose or predefine LUN20. Click OK and click OK. At this point, LUN20 is now configured with a predefined disaster recovery plan. In the event of a disaster that impacts my stretch cluster in both primary and secondary live volumes, we can recover the LUN20 volume at our DR site using Enterprise Manager, and it will map that data store up to our vSphere host automatically for us with just a couple clicks of the button. Now let's go back over to the vSphere web client and let's migrate all of our virtual machines from one host to the other host in our stretch cluster. If I look at the location of my virtual machines, it appears that they're all located at this point on the host TSSRV 214. I have no virtual machines on TSSRV 215. Let's go ahead and place this host into maintenance mode, and this will in essence force or invoke an evacuation of those virtual machines. At this point, all of my virtual machines have been evacuated off of the host TSSRV 214, and that host is now entering maintenance mode. If I highlight the other host in my stretch cluster, I can see that now that all the virtual machines and templates have been moved over to that host. We have essentially just performed a vMotion across a stretch cluster. Because these virtual machines reside on a live volume that's stretched across both nodes of the stretch cluster, these virtual machines now have local access to local storage on the storage center at the remote site. Back in Enterprise Manager, I can see that the LUN10 live volume, where these virtual machines and templates reside on, has automatically performed a swap role. At this point, the primary live volume for our stretch cluster for LUN10, which these virtual machines are residing on, is now on the 64424 storage center. The secondary live volume is on the 64422 storage center, which is the storage center in the location where I just placed the vSphere host in maintenance mode. At this point, the virtual machines that have been migrated to the remote data center in our stretch cluster now have local storage, which resides in that local data center. Back in the vSphere client, I've taken the TSSRV 214 host out of maintenance mode, and at this point I'm going to power off the storage center at the remote data center where TSSRV 215 lives. And at that point I'll demonstrate one of the new features in Storage Center 6.5 in Enterprise Manager 2014 R2 for preserving and recovering a primary live volume. The storage center is now powered off, and I can see that the storage center is down via Enterprise Manager. If I go over to my vSphere web client, I can see that my virtual machines that were on that storage center are now inaccessible because the primary live volume has been shut down. Now I'll use Enterprise Manager to recover the primary live volume. I'll choose Activate Disaster Recovery. I'll choose the source and destination storage center pairs. Click Next. Next. I'm going to recover the LUN10 live volume. I'm going to edit settings. I want to make sure that the checkbox for Preserve Live Volume is checked. This is what allows us to recover the primary live volume at the remote storage center without having to unregister and re-register virtual machines. Click OK and finish. At this point, the primary live volume has been recovered on the remote storage center. If I go back to my vSphere client, right-click on the cluster, choose all vCenter actions, and then rescan storage, we should be able to see that LUN 10 is accessible. Back in the vSphere client, I can see that our stretched datastore LUN 10 is once again available and visible on TSSRV 214. At this point, when properly configured, vSphere HA can automatically migrate the powered off virtual machines from one host in the cluster to the other, in this case TSSRV 214. They can then be powered on automatically or manually via vSphere HA. The key thing to remember is that we're able to recover the virtual machines without having to unregister and re-register them because the identity of the volume has not changed. For the last task, I've gone ahead and shut down Storage Center 64422. At this point, both storage centers in my stretch cluster data center configuration are shut down, and I've got a disaster on my hands. So we'll go ahead and use the predefined DR feature for managed replications to recover our managed replication live volume and our virtual machines at our DR site. To do that, I'll go to Replications and Live Volumes. I'll go to my restore points, and I'll choose Activate Disaster Recovery. I'm going to choose the storage center pair. Click Next. And the first volume or data store that I want to activate for my Tier 1 virtual machines is my LUN 10 live volume. In this case, I'm not going to actually be able to recover the live volume, but I'm going to be able to recover the data preserved in the managed replication that live volume replicates to my DR site. I can choose Edit Settings. Notice I don't have the Preserve Live Volume option here. We cannot preserve the primary live volume at the DR site. At this point, we can recover either from the active replay or from a historical replay. If I take a look at the advanced mapping, notice once again from my predefined DR plan, we're going to map this volume using LUN 10 for consistency, and my DR server, all of this information was already predefined, so I don't really need to worry about it at this point, but I can verify. This is my DR vSphere host, TSSRV 256. Click OK. Click Finish. Okay, at this point, I can see that my restore state is finished, and the volume, my LUN 10 data store, should be presented to my DR vSphere host. Let's go check that out. I'll go back to the vSphere web client. I'm now in my DR data center. I'll choose my DR host or cluster, right click, choose all vCenter actions, and rescan storage. We'll scan for new storage devices as well as VMFS volumes. It should find both. Now that the fabric rescan is complete, we can go to Related Objects, choose Data Stores, and we'll add our data store. We should be able to find LUN 10 has been added. We'll click Next. We can assign a new signature or keep the existing signature. Click Next and Finish. At this point, our LUN 10 volume, our data store, is added. So at this point, we can go ahead and register our virtual machines. So this is going to be a process at your DR site that you're going to perform either manually through the data store browser, or perhaps you have an automated PowerShell script that will do it for you. So I've got 5 virtual machines to register here, and I will select each VM folder to register the VMX file. Click OK. That virtual machine is going to be registered, and it's going to live on the DR data center. In the DR cluster, click Next. That's the only host I have, and Finish. Okay, all 5 virtual machines that were previously powered on in my production data center are now recovered at my DR site. I simply need to power them on. So I'll go to the Virtual Machines tab, highlight all 5 virtual machines, assuming that it's safe to bring them all up in the same order at the same time, and choose power on. Now the net result of this recovery is that the device path for each virtual machine has changed, so we need to acknowledge the question about whether we moved or copied this virtual machine. So I'll do that for each one as the last step to power it on. Answer the question, say I moved it. That way it doesn't change the MAC address of any of the NICs. In most cases that doesn't matter. And by the way, if you have a scripted process to register the virtual machines and power them on, this task of answering these questions can easily be scripted. With 5 virtual machines, it's not a great task to handle, but as you can imagine, with a larger number of virtual machines, this could be a bit tedious. And frankly, this is where vSphere Site Recovery Manager comes in to manage the registration of the virtual machines, powering them on in correct order, managing dependencies, changing IP addresses, things like that. Okay, at this point, all 5 of my virtual machines are powered on. They should be booting up. I can see one of them from the thumbnail image. It's already got a Control-Alt-Delete screen. So, demonstrated a few methods of recovering a primary live volume, swapping the roles of a primary live volume by migrating virtual machines between a stretch cluster site, as well as recovering a live volume data store at a DR site. Thank you very much for watching. For more information, please visit dellstorage.com or Dell Tech Center to get more information on Dell Compellent Storage Center, as well as live volume and synchronous replication solutions.